I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on redox reactions. So our lesson objectives for today's lecture, at the end of the lesson, the student should be able to define oxidation number. What is oxidation number? The student should be able to state the use of oxidation number, calculate the oxidation number of elements in a compound. So please, I want us to listen attentively and get the best from today's lecture. Thank you very much. Please listen attentively. Now we're looking at oxidation number. We'll talk about oxidation number. Oxidation number can be defined as the charge on an ion. That is the oxidation number, the charge on an ion. It is also the number of electrons on the valence shell of an atom, otherwise known as the valence electrons, or the number of electrons required by an atom to acquire a free electronic structure. That is the number of electrons an atom have to gain or lose in order to attain its noble gas configuration. In order to attain the noble gas configuration, to complete its octet or duplet state. So it is the number of electrons an atom required to acquire a filled electronic structure. Let's take, for example, sodium, for example. Let's take sodium, for example. Sodium is 11, so which is 281. If you draw the electronic structure 281, that means it has one electron in the outermost shell. So it has to lose one electron to attain the noble gas configuration. So the oxidation number of sodium is +1. So the oxidation number of sodium is equal to what? +1. Now, if you look at nitrogen, for example, nitrogen is 7. Nitrogen has 5 electrons in the outermost shell, which is 2, 5. So it needs 3 electrons to complete its octet state. So it will be what? N3 minus. So oxidation number of nitrogen is equal to what? Minus what? Minus 3. So it is the number of electrons on the valence shell of an atom, otherwise known as the valence electrons, or the number of electrons required by an atom to acquire a filled electronic structure. So the number of electrons an atom have to gain or lose in order for it to attain its noble gas configuration. Like sodium has to lose 1 electron to attain the noble gas configuration of neon, while nitrogen has to gain 3 extra electrons to attain the noble gas configuration of neon as a noble gas. So it's as simple as ABC. So oxidation number can be defined as the charge on an ion, or the number of what? Electrons on the valence shell of an atom, otherwise known as the valence electrons, or the number of electrons an atom have to gain or lose in order to attain its noble gas configuration. So it's as simple as what? A, B, C. Now I want to look at oxidation number, uses of oxidation number. Having considered oxidation number, which is the charge on an ion, or the number of electrons an atom have to gain or lose in order to attain its noble gas configuration, we want to look at the use of oxidation number. Now, one is that oxidation number is used to know which atom is oxidized or reduced. Yes, with the help of oxidation number, we can tell the atom that undergoes oxidation or the atom that undergoes reduction in a reaction. That means the atom that is oxidized or reduced. Then the second one is it is used in classifying elements into a particular group on the periodic table. We know that oxidation number can be defined as the valence electrons, the electrons on the valence shell of an atom. So it is used to what? It is used in classifying elements into a particular group on the periodic table. Then number 3, it is used in balancing half-cell equations. Yes, we use oxidation number to balance half-cell equations, both simple ionic equations and complex ionic equation. Then number 4, it is used in the IUPAC system of naming. So what we talk about IUPAC means International Union of Pure and Applied Chemists. So International Union of Pure and Applied Chemistry. So it is used in the IUPAC system of naming. Inorganic compounds. We call it the IUPAC system of naming, both organic and inorganic substance. So oxidation number is used in the IUPAC system of naming. So these are the uses of what? Oxidation number. So still on oxidation number, we want to look at the rules for calculating oxidation number. We'll talk about oxidation number, which is the charge on an ion, or the number of electrons an atom have to gain or lose in order for it to attain the noble gas configuration. So rules for calculating oxidation number. The first one is, number 1 is all elements have an oxidation number of 0. Yes, all elements in their ground state, they have an oxidation number of 0. For example, this is sodium. The oxidation number of sodium here will be equal to what? 0. All elements have oxidation number of 0. As far as an element, you have oxidation number of 0. Hydrogen is equal to 0. All elements have oxidation number of 0. Then the second is charges on ions are their oxidation number. So if I have Ca2+, the oxidation number of calcium here is equal to +2. If I have NO3-, the oxidation number of nitrate ion here is equal to -1. If I have SO4 2 minus, the oxidation number here is equal to what? -2. So the charges on ions are their oxidation number. Then number 3, all compounds with a net charge have an oxidation number of 0. All compounds without a net charge, all compounds without a net charge have an oxidation number of 0. For example, carbon dioxide without a net charge, there's no charge, so the oxidation number is equal to what? 0. Water, the oxidation number will be equal to what? 0. All compounds without a net charge have an oxidation number of 0. Then number 4, if a compound has a net charge, the sum of its atom charges must equal the net charge. Yes, for example, if I have SO4 2 minus, which is a compound with a net charge, then the sum of what? The charges on sulfur and oxygen will equal to what? Will be equal to -2. If a compound has a net charge, the sum of its atom charges must equal the net charge. That means the sum of the oxidation number, the sum of the charge on sulfur and oxygen is equal to -2. The same thing, NO3 minus, the sum of its atom, which is nitrogen atom, the sum of the charge on nitrogen must be equal to the net charge. The sum of the charges on nitrogen and oxygen must be equal to what? -1, which is the net charge. Then number 5, hydrogen has a +1 oxidation number when found in a compound, but -1 in hydride. Hydride is a compound that is formed when metals react with hydrogen, like sodium hydride. The oxidation number of hydrogen here will be equal to what? -1 in hydride. Hydrogen has a +1 oxidation state when found in other compounds, but in -1 in hydride, only in hydride. Hydride are compounds of hydrogen and metals. So when found in hydride, the oxidation number will be equal to what? -1. For example, CaH2, this is another example, calcium hydride, the oxidation number is -1 in hydride, but +1 in compound. Then number 6, oxygen has a -2 oxidation number when found in compound, but -1 in peroxide, like hydrogen peroxide, the oxidation number is -1. Barium peroxide, the oxidation number is -1. But in other compounds, the oxidation number is -2. So oxygen has a -2 oxidation number when found in compounds, but in peroxide, it is what? -1. So it's as simple as ABC. These are the rules for calculating oxidation number. So please, I want us to take note of these rules because it will go a long way to help us in calculating the oxidation number of an element in a compound. So it's as simple as what? A, B, C. So having considered the rules for calculating oxidation number of an element in a compound, or for calculating oxidation number in general, we want to calculate the oxidation number. What are the oxidation states of the elements in the following? So the first one, the oxidation state of carbon here will be equal to what? 0. The state of carbon here will be equal to 0. Oxidation number of ion 2, which is equal to +3, that is the oxidation state. Oxidation number of ion 2 here is equal to what? +2. Oxidation state of oxygen here is equal to -2. Oxidation state of helium is equal to what? 0. And oxidation state of what? Aluminium is equal to what? +3. So that is the oxidation state of each of these what? Elements. So before it's a quick examination question on calculation of oxidation number. Now, what is the oxidation number of nitrogen in magnesium nitride? So you have to calculate the oxidation number of nitrogen, which is an element in a compound magnesium nitride. Now, all compounds without a net charge have an oxidation number of 0. So what happens is that what magnesium nitride, which is Mg3, N2, all compound without a net charge. So there's no net charge. The oxidation number is equal to 0. But we want to calculate the oxidation number of nitrogen. So it will be 3 bracket what? Oxidation number of magnesium is 2 plus 2 bracket nitrogen is equal to what? 0. So it's the oxidation of nitrogen we are calculating. 3 times 2 is what? 3 times 2 is 6 plus 2n will be equal to what? Will be equal to 0. So collect like terms. 2 nitrogen will be equal to 0. When they come back to this side, it's equal to 0 minus 6. So 2 nitrogen, 2n will be equal to what? Minus 6. So divide both sides by 2. Divide here by 2 to get the oxidation number of nitrogen. You cancel out. Nitrogen now will be equal to 2 here, 1, 2 here is equal to what? Minus 3. So the oxidation number of nitrogen in magnesium nitride Mg3N2 is equal to what? Minus 3. So the correct answer to this question is B, which is equal to what? Minus 3. So it's as simple as what? ABC. Attempt as many questions and feel free to reach out to me if you encounter any challenge or any difficulty. So before it's an exam style questions, so it's on redox. The question is about redox chemistry. Define the term reduction. So in terms of electron transfer, reduction is the gain of electron. In terms of oxygen and hydrogen, reduction is the addition of hydrogen and removal of oxygen. In terms of oxidation number, reduction is decrease in oxidation number. So it's as simple as ABC. Then the next question is state the oxidation number of the named element in each of the following compounds. So we have to calculate the oxidation number of the named element in each of the following compounds. So we have to calculate the oxidation number of manganese. We have to calculate the oxidation number of manganese in what? KMnO4, potassium manganate. So it will be what? Oxidation number of potassium is 1 plus manganese plus 4 bracket minus 2, which is the oxidation number of oxygen minus 2 will be equal to 0 because it's a compound without a net charge. All compounds without a net charge, they have an oxidation number of 0. So it will now be 1 plus what? Manganese. 4 times minus 2 is minus 8 will be equal to 0. So 1 minus 8 plus manganese will be equal to 0. So minus 7 plus manganese will be equal to what? 0. Manganese will now be equal to what? 0 plus 7. So minus 7 will cross over, you give it plus 7. So oxidation number of manganese here will be equal to what? Plus 7. So oxidation number of manganese in potassium manganate is equal to what? Plus 7. That is for 1. Then for II, you have to calculate oxidation number of nitrogen in nitrogen oxide, NO2. So nitrogen, oxidation number of oxygen is minus 2, which is 2 bracket minus 2 is equal to 0. A compound without a net charge. So it will be nitrogen, 2 times minus 2 is minus 4, is equal to what? 0. Nitrogen now will be equal to what? 0 plus 4. When you cross over to 0 plus 4, so oxidation of nitrogen is equal to what? 4. So oxidation of nitrogen here is 4. So I have to erase so that I'll have enough space to calculate others. The next one is you have to calculate the oxidation of nitrogen in nitric acid, which is HNO3. So let me erase so that I'll have enough space. So number of nitrogen, oxidation number of nitrogen in nitric acid. So its oxidation number of nitrogen is plus 1, plus oxidation number of hydrogen is plus 1. Hydrogen is plus 1, plus nitrogen, plus 3 bracket what? Minus 2 is equal to 0, which is a compound without a net charge. It will be 1 plus n. Nitrogen minus 6 is equal to 0. So 1 minus 6 plus nitrogen is equal to 0. Minus 5 plus nitrogen is equal to 0. Nitrogen now will be equal to what? 0 plus 5. Nitrogen will be equal to what? 5. So oxidation of nitrogen in nitric acid is what? Plus 5. Then V, you have to calculate the oxidation number of chlorine in hydrogen chloride. So it will be HClO, which is oxidation number of hydrogen is 1 plus chlorine. We are looking for the oxidation number of chlorine plus bracket minus 2 is equal to 0. So you have what? 1 plus chlorine minus 2 is equal to what? 0. So it will now be 1 minus 2 plus chlorine will be equal to 0. Minus 1 plus chlorine is equal to 0. So chlorine now will be equal to what? Minus 1 will cross over to be 0 plus 1. So the oxidation number of chlorine here is equal to what? Plus 1. So which is oxochlorate what? Oxochlorate 1. So it is HClO. So it's as simple as ABC. That is how you calculate the oxidation number of elements in a compound. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So feel free to reach out to me if you encounter any challenge. So before us again is a typical examination question, exam style question. The following reaction can be described as a redox reaction. Manganese 4 oxide reacts with hydrochloric acid to give you manganese chloride, water, and chlorine. Identify the element that has been oxidized. Identify the element that has been reduced. From our previous lecture, we are meant to understand that oxidation is the increase in oxidation number, while reduction is the decrease in oxidation number. That is the definition of oxidation and reduction in terms of oxidation number. So whenever there's an increase in oxidation number, that is oxidation. Whenever there's a decrease in oxidation number, that is reduction. Now, the first thing we're going to do, we're going to, write down the oxidation number of each of the elements that is what present. So we'll calculate the oxidation number of each of the reactant and the product. So we can identify the oxidation number of each of the elements that is present. First, we'll start with manganese oxide. Calculate oxidation number of manganese in manganese 4 oxide. So it will be manganese plus 2 bracket minus 2 is equal to 0. A compound with a net charge is equal to what? 0. So we'll have manganese minus 4 is equal to 0. Oxidation number of manganese here will be equal to what? 4. So oxidation here is plus 4 for manganese. Oxygen is minus 2. Oxidation number of hydrogen in hydrogen chloride. So as hydrogen plus what? Bracket minus 1 for chlorine is equal to 0. So hydrogen now will be equal to minus 1 is equal to 0. So oxidation number for hydrogen will be equal to what? 0 plus 1, which is equal to 1. For hydrogen will be plus 1. Chlorine will be minus 1. Oxidation number for manganese chloride, let's calculate it. Manganese plus 2 bracket minus 1. Oxidation number for chlorine is minus 1. Is equal to 0 since it's a compound without a net charge. So it will now be what? Manganese minus 2 is equal to 0. So oxidation number for manganese now will be equal to what? 0 plus 2, which is equal to 2. So oxidation of manganese here is plus 2. Oxidation here is for chlorine. So let's calculate the oxidation number for chlorine since we know that of manganese, which is plus 2 bracket chlorine be equal to 0. So you have what? 2 plus 2Cl will be equal to what? 0. So 2Cl will be equal to what? 0 minus 2. 2Cl will be equal to what? Minus 2. So that means chlorine now will be equal to what? Minus 2 divided 2 will be equal to minus 1. So oxidation number for chlorine here is minus 1. Oxidation number for hydrogen here will be plus 1. Oxidation number for oxygen minus 2. Oxidation number for chlorine is 0. So we're going to look at the element that has been oxidized and the element that has been reduced. It's based on the oxidation number. Oxidation is the increase in oxidation number. So for manganese, it is from plus 4 to plus 2. That is decrease in oxidation number. Decrease in oxidation number. So the element that has been what? Reduced. The element that has been reduced is manganese has been reduced because there's a decrease in oxidation number. Then the element, if you look at chlorine, from minus 1, there's an increase in oxidation number minus 1 to 0. So the element that has been oxidized is chlorine. Then the element that has been reduced is manganese. So manganese is reduced from plus 4 to plus 2, while chlorine is oxidized from minus 1 to 0. So it's as simple as what? ABC. Use the concept of oxidation number and calculation of oxidation number to identify the element that has been reduced, that has been oxidized, and the element that has been what? Reduced. So it's as simple as what? ABC. So what you do, you just calculate the oxidation number of each of the element that is present on the reactant and also on the product, and identify the element that has been oxidized and the element that has been what? Reduced. For on the reactant, hydrogen remains plus 1, and on the product, hydrogen also remains what? Plus 1. On the reactant, oxygen remains minus 2, while on the product, oxygen still remains minus 2. So the only thing that changes is what? Manganese and what? Chlorine. Manganese changes from what? From +4 to +2. That is decrease in oxidation number, which is reduction. So manganese is reduced. Then chlorine changes from what? -1 to 0, which is increase in oxidation number. So what happened is that what? Chlorine has been what? Oxidized. So it's as simple as A, B, C. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. So I believe in this task for us to work on is a typical examination question. Please attempt the question and also attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty in the process of trying to solve the question. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. So attempt this task. Manganese has many oxidation states. What is the oxidation state of manganese in each of the following compounds? So it's as simple as what? A, B, C. So attempt this and reach out to me if you encounter any difficulty. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, Joe Mystery, and feel free to reach out to me if you encounter any challenge or any difficulty while trying to attempt the questions. I'm always there for you. I'm Mr. Joe, your chemistry teacher.